talk about okay, so we're in day 3 of our NeSA review, and so first of all, we're going to review some triangle classifications, which is something that you should remember from geometry. Okay, and so first of all, if I was to tell you that you have an acute triangle, what can you tell me about an acute triangle?
Less than 90.
What is less than 90?
Angle.
Okay, all angles are less than 90 degrees. Okay, so what about an obtuse?
All angles are greater than 90. Well, wait, one angle is greater.
One angle is more than 90. You can't have two more than 90 because your triangle only measures 180 degrees. What about a right triangle? One angle is 90 degrees. Okay, so those are just a review. Acute, obtuse, right. Those are classified by angles. These 3 are classified by sides. What's a scalene triangle?
All sides are different.
All sides are different. Okay, what about an isosceles? 2 sides are the same. And what about an equilateral? All sides are the same. And a little bit about an equilateral triangle. All sides are the same, which means that all angles are the same, and all angles are actually 60 degrees. Okay, so those, like I said, should be review. Okay, we've went through those. And so what we're going to do is we're going to now look at some triangular problems.
These are my
Okay,
favorite.
so, well, I'll go back. If you didn't quite get those down, I'll go back and you guys can get those at the end. It says, if a triangle is equilateral, find the length of H. Okay, so if a triangle is equilateral, find the length of H. And so if you look at that triangle, and I don't have this marked, but this is actually a 90-degree angle. If it's equilateral, we know all the angles were what? 60. So that means this is a 60-degree angle. This is a 60-degree angle. And up here, those are split. So each one is 30. So there's 2 ways to find H. What's one way? Pythagorean theorem. Okay, that's one way. The other way is to recognize that's a 30, 60, 90 triangle, in which case those sides have a certain relationship that we learned about last year. Okay, so that's probably the easiest way if you can remember what the relationship is. Okay, the side opposite 30 is always half the hypotenuse. Okay, and then how would I find H? H is actually root 3 times my shortest side. So what would H be in that problem? 10 root 3. Okay, but you forget on the NeSA, and you're going to have to do this. Now, where this becomes a problem is that when we simplify it, you'll see what ends up happening. So 100 equals 400, because remember, you don't have a calculator. Okay. So if I subtract 100, I get H squared to equal 300. And then now, what do? Square root. And like I said, now's where the kind of the problem is if you don't remember that relationship that we discussed last year. Because I have to break 300 down. Okay, and I already know it's 3 and 100. And 100 I could break down like with the 2's and that, but 10 and 10 stops me right away. Okay, because I've got my pairs here. And so then really I end up getting 10 root 3. So I get there. It's just not as quick.
You said it's root 3 times.
The shortest side. And here's the shortest side right here. The shortest side is always opposite, the side opposite 30 degrees. Okay. So if you recognize that, you can answer it fairly quick. If you don't recognize that, you can go through and use the Pythagorean theorem, but then understand you're going to have to simplify at the very end. Okay. So that was a 30, 60, 90 triangle. If the triangle is equilateral, find the length of H. So let's try to remember what I just talked about. Okay, well, remember from last year too. this is 60 degrees, right? And I want to find what H is.
10.
How'd you get 10?
Pi of
You're right. This is a 30, 60, 90 triangle, and if you remember what I just said, okay, your shortest side is half the hypotenuse. So if I want to find the hypotenuse here, I just take 5 times 2. Just for kicks, so this would be 10. What would this vertical line be? 5 root 3. So it's always the shortest side times root 3.
Does this only work for equilaterals?
It works for any 30, 60, 90 triangle.
Oh.
Yep. Any 30, 60, 90 triangle will fit that. So then now we're going to look at a 45, 45, 90 triangle. The thing about a 45, 45, 90 triangle is that how many sides are the same? 2. So once again, there's 2 ways to do this. Okay. First way is I know that this side is 6, so I could use the Pythagorean theorem, which is great. I have 6 squared plus 6 squared equals h squared. 6 squared is 36. So really I have 36 and 36. And what's 36 and 36? 72. So then now once again we're back to kind of the downfall if we don't remember our nifty little rules. And I have to take the square root of each, and then I have to break down 72. What can you tell me about 72? 8 and 9? Okay. And then 8 is what? 2 and 4. And then 2 and 2. What about 9? 3 and 3. So what are we taking out? We're taking out 1, 3 and 1, 2. And so really what am I taking out total? 6 root 2. Okay, that's one way. The other way is in a 45, 45, 90 triangle, the hypotenuse is always root 2 times one of the legs. Okay, the hypotenuse is always root 2 times one of the legs.
The legs will always be the same though, won't they?
What?
The legs will both be the same, right?
Right. So the hypotenuse is always root 2 times one of the legs. And let's go ahead and look at this one because notice this one, they give you the hypotenuse, they don't give you the leg. So there's 2 ways to view this. One, this is h, and I could go through and use the Pythagorean theorem. Okay, so h squared plus h squared equals 12 squared. Or let's think about what we had to do. If I knew this, I took this times what to get the hypotenuse? I took it times root 2. So if I want to go backwards, what am I going to do?
It's -2 power.
Okay, let's think about that. I take it times root 2 to get here. What undoes timesing? Dividing. So in order to go backwards, I'm going to take 12 and divide it by root 2. Now, granted, you know you can't have that square root in the denominator, so what are you going to have to do?
Multiply by root
Root 2 over root 2. Okay, which is really 12 root 2 over what?
2.
2, which answer is?
6 root
6 root 2. Okay. Or, worst comes to worst, you forget, you've got this option. Okay, this tool. It's going to take you a little longer. H squared and h squared is 2h squared. 12 squared is 144. What do you do now? Divide by 2, so h squared equals 72. And we just broke down 72 on the slide before, and we found that to be 6 root 2. So you will get the exact same answer both ways. And you're also going to have multiple choice. Okay, so it's one of those things you will have a correct answer to look at. Questions on the 45, 45s, 30, 60s? All right, real quick. if I gave you this problem, what do you think you should do?
Graph it.
Graph it, okay? You've got graph paper, might as well graph it so you can see a visual. So you have -1, -2, you have 3, 4, and you have 7, -2. And you have to determine what type of triangle is this. So first of all, in looking at it, is it a right?
No.
No, so you can throw that out. So now you have acute isosceles or acute scalene. So this is the easy way to figure it out, if it's isosceles or not. Count your vertical, and what do you get here? 6. Count your horizontal, what do you get? 4. I'm going to do the same thing over here. If those numbers match exactly, it's got to be the same measure. Okay, if they don't match, then you know they're different. So here I'm going to go up 6. What do I do here? Over how many? 4. So those match. If I use the Pythagorean theorem, I'll get the same length of the sides. So this is actually an acute isosceles. Find the measures of the missing angles.
These are my
I
favorite.
like these.
Okay, yes, you will have these. These are like your alternate interior, alternate exterior, things like that. So let's go ahead and look. First of all, I have ABE. ABE is right here. Remember, the middle letter is always our vertex of our angle. So what will ABE equal?
50.
50. Why 50? A straight line is 180. You've already used 130. AEB, what's that got to be if this one's 50?
75.
Nope. 75.
So first of all, you know a triangle adds up to be what?
180.
180. I've already used 50 and 55. So that means this one has to be 75 degrees. Angle C, what's that got to be?
50.
50 because, now granted, one of the things I should have told you,
No, you didn't say it was parallel.
I know I didn't say it was parallel, I should have told you it was parallel. Okay, I missed that one, they are parallel.
That's a big,
Okay.
that's a big thing.
So, they are parallel, so that one is 50. What about angle D?
75.
75.
Those are my fave. I
Okay,
do those in my sleep.
so that should be review. We did a lot of those
I like
last
geometry.
year. Okay? All right, find the volume. We've got a few problems left on find the volume. Now, one of the nice things about this is you've got the volume formulas. Okay, volume formulas are on the side here, second one down. But you shouldn't need the formula for this one. What's the volume of this three-dimensional figure?
2,400. Oh,
5
240.
times 4 times 12.
I'm always wrong in person.
Okay?
Second.
Hey, enough.
140.
5 times 4 times 12, which is what? 240. Label will be
Centimeters cubed.
centimeters cubed. Okay. What about that one?
Ooh.
The easiest way to remember volume, it's the area of the base times the height. So the base is the figure that's repeated twice. And so in this case, the base is actually this triangle here. So I'm going to find the area of that triangle. The area of that triangle should be pretty easy because triangle is base times
Height divided by 2.
height divided by 2. So in this case, base times height is,
24.
divided by 2 is,
12.
so that's the area of the base. I'm going to take that times the height of this prism, and what's the height?
1.
1. So what will be the volume? 12 feet cubed. So area of the base times the height, and I believe that that's on there. Okay, the right prism one, the volume one, it says big B times H. They've got a key that big B up here is the area of the base.
Does it matter if you write feet cubed or cubic feet?
It'll be multiple choice.
Oh, okay.
So that'll be one of the things that you'll have to watch. Okay, so once again, now on this one, I will tell you this much. You're not going to be able to fully calculate this problem, okay? Because it's going to have pi in it, and it's going to be one of those things that they aren't going to want you to get bogged down with the computations. So what they're gonna just have you do is put down kind of what you multiply. And so in this case, the area of the base, what's the area of this gonna be?
Pi r squared.
So pi times 4 squared, right? So that's the area of the base. What am I gonna take that times? 9.5. So my guess is they're gonna have something like this, and you're just gonna have to find that. Okay, now one of the things,
They won't have you figure out what 4 squared is?
well, they might, but they probably aren't gonna have you figure out that whole thing, because that is kind of a computation that would take a little bit of time.
But not for you, right?
So anyway,
Tell us what
that
that is.
is section 3. Okay, so any questions?
If we have, is there a cylinder one on the worksheet? Do we have to do it all?
Nope, answer it just like I did. Alrighty.